To study biomechanics, the way we move, university students and researchers in Bath are mapping the skeletons of, well, skeleton. A sport where athletes plunge down an icy track, head first and face down, reaching speeds of up to 130 kilometers an hour.
It feels like nothing I've ever experienced before. When it feels good, it feels really good. When it feels bad, it feels really bad.
Here you'll notice a key difference: no ice. This is the UK's only outdoor training tracks dedicated to those precious and precise first few seconds, the push start.
If a race is completely standardised and everything is exactly the same, 1/10 gained in the push is equivalent of about 3/10 at the bottom, so everything matters.
But let's rewind. Because something else is happening at this track.
Okay, aperture open.
This morning, long before Matthew and his fellow athletes arrived for their training session,
we will be pushing from this block today.
Another team was hard at work.
Like half on the track?
Yeah, I've gone at 15 and 5, and then I'll just fill in the middle.
From the university's Center for the Analysis of Motion, Entertainment Research and Applications, or CAMERA, this track isn't just a training ground, it's a testing site. Team has developed a motion capture system using specialized cameras to collect data on the way skeleton athletes move. What makes the tech unique is what you don't see. No dots, no sensors, no bodysuits. This is completely markerless.
The cameras are placed to give us the best chance of capturing as much of that information as possible. So we want to see the entire athlete body and sled in the frame that should be happening through this middle section. And ideally you have multiple cameras capturing that at any given moment in time.
Mike Muckelt is a biomechanics PhD student at the University of Bath. So successful working with the push start data, the British bobsled and skeleton team actually hired him in 2022.
Skeleton is also an extremely asymmetrical movement. The constraint that you have to run in a bent over position and hold the sled with one arm whilst the other one is freely swinging means that you actually run in a very asymmetrical way. So a lot of Mike's work, his PhD work, has been characterising that asymmetry.
Ultimately, as an athlete, you want to just turn up and you want to just do your training session. So if you can not be invasive in that process, then that's the best kind of data collection.
The benefits today was I was able to execute more of a race style preparation of taking off my kit and getting ready to go. Whereas if I had a load of markers all over me, they'd fall off or they'd be covered or something like that. So it just enabled it to be a bit more realistic of what I'd actually do.
Unburdened by those markers, the sensors we're used to seeing for motion capture means the computer software is trained to identify landmarks on the human body.
And then you reconstruct that into 3 dimensions by having multiple cameras that are seeing the same landmark, pelvis for example, or maybe like the top of your shoulder. And from that you can reconstruct that image in 3 dimensions, and then you're going to get basically a coordinate system in 3 dimensions.
And from this we can look at joint angles, we can look at joint positioning, how quickly they're moving, we can look at things like step length and step frequency.
The next evolution of the research includes studying motion in other sports like tennis and badminton. Perhaps most impactful are the possibilities away from the field of play.
In terms of future applications, it's limited only by the user's creativity. I would say we're in quite an early stage of the development of this sort of system.
There's a huge need for motion analysis in healthcare, for doing clinical gait analysis, for monitoring someone's rehabilitation from things like strokes. This is a very rapidly evolving field, and what it promises to allow us to do is take things out of the lab and do things on scale that we haven't been able to do before.
And it all started here. While these athletes have their sights set on the 2030 Winter Olympics, Mike plans to attend his first Olympic Games as a coach this February in Italy, equipped with everything he's learned from this tech on the track.
We're taking those things, we're applying them to athletes, we're making the athletes better as a result of it. But when I get to understand the data build a better understanding of what's happening in the sport context, and then actually apply that to an athlete to drive an outcome that's ultimately going to help them achieve their goal of, in our world, becoming Olympic champion.
These students have taken us along for the ride as their tech builds a brighter, safer future for the adrenaline-fueled world of sport.
Yeah!